Good morning, everybody. Thanks for joining our webinar today. This is Josh Valentine with the Clean Coalition, Communications Manager for the organization. This is our next webinar on our North Bay Community Resilience Initiative, that kicked off early this year. This one is Advanced Energy Programs and Strategies in the North Bay Community Resilience Initiative. I just want to go over a few technical things for the webinar. Before we begin, the webinar recording and slides will be sent to registered attendees within 2 business days. That usually happens within 1 day, so you might see it tomorrow. All webinars are archived on our website at clean-coalition.org and our YouTube channel. We will be having a Q&A session after the presenters are done with their presentations. So if you want to ask a question and possibly have it answered, please enter it into the question box on your GoToWebinar control panel. We will do our very best to get to it at the end of the webinar during the Q&A session. If you have any technical questions or any other general questions about the Clean Coalition or the webinar in general, contact me, Josh, at clean-coalition.org. All right, so speaking today, we have Rachel Kuykendall. She Sonoma Clean Power's program manager and was responsible for program design and implementation in the areas of distributed renewable energy, energy efficiency, demand response, electric vehicles, heat pumps, and other related areas that reduce greenhouse gas emissions and support affordable energy for customers. Our next presenter is John Sarter, founder of Microgrid Development Group, and an independent builder and entrepreneur in the converging fields of real estate, energy, and transportation. John is a recognized innovator in developing the renewables plus storage space since 2008 and founded the Microgrid Development Group in San Francisco to unite a consortium of energy, technical, engineering, and other professionals committed to creating a resilient and sustainable distributed and renewable energy future. Once again, if you have questions, please contact me, Josh, at clean-coalition.org. So I'm going to pass it along to Greg Thompson. Greg works for the Clean Coalition as a director of the Community Microgrid Initiative, and he is leading this charge on the North Bay Community Resilience Initiative, and he's going to give a general overview of what that's all about before we hand it off to Rachel.
All right, thank you, Josh. Good morning, everyone. And thank you for joining our webinar today on the North Bay Community Resilience Initiative. This is an initiative where a lot of folks are joining together to collaborate and help bring, a better solution to our communities, given the fact that we've had, those tragic wildfires in the area and other places in California as well, and across the country, issues with extreme weather. So I'm going to take 5 minutes just to provide a little bit of upfront context, and then I'm going to hand it off to Rachel. The focus of today's webinar is really about the home rebuilding side, and that's why we've got, fortunate to have Rachel present that program to those watching this webinar, and then John following up with the sort of vision around what it means for modern homes and buildings to be both energy efficient and reducing greenhouse gases, and also interoperating better with the grid. So first, the Clean Coalition is a nonprofit. Our mission is to accelerate the transition to renewable energy and a modern grid through technical, policy, and project development expertise. We have expertise in a variety of areas. We work through detailed analysis and planning, things like the full cost and value for distributed energy resources. We do grid modeling and optimization analysis, power flow modeling. How do you put DER into the right locations and the right amounts in the right portfolios? We do program and policy design to advance how the grid and utilities and policies impact this new modern grid featuring distributed energy resources. And then finally, that leads to community microgrids, which is really a collection of all of these things put together for communities in the most beneficial way, both economically for communities as well as in terms of things like resilience and how the grid operates, and of course, clean energy being the feature and the focus. So we do design and implementation of those projects. And the North Bay Community Resilience Project that we're talking about today is an example of one of those. 1 second. Okay, for some reason I'm not able to advance the slide.
Greg, maybe click on your PowerPoint itself, and I think maybe you veered away from it.
Okay, thank you.
Sure.
There it is. So the community microgrids are really what we see as the grid of the future. So it's modern and more cost-effective solution for designing and operating the electric grid. Key features and benefits, I'll go quickly through this. They're targeted and coordinated local grid area served by a substation or more than one. This is the most cost-effective way to use and operate energy. It's clean local energy, it's energy storage and other distributed energy resources in optimal portfolio, so not random, but really targeted and focused on the most cost-effective solution for communities. It lowers system costs while also satisfying things like local EV transportation, which we know has to increase. And it provides resilience. So we don't have resilience in a centralized grid. Along with the cost-effective benefits of clean local energy and community microgrids, we also have resilience. So that's ongoing renewables-driven backup power serving both critical and prioritized loads across a grid area. And then it's replicable. This is a solution that can be readily extended throughout a utility service territory and replicated really across the world. So it's a cookie cutter blueprint way to operate the distribution grid for the benefit of everyone, including those who operate the grid. And it features what we call local balancing. This is just repeating a little bit of what I said, but we want to talk about local balancing as where the distribution and transmission grids become equal partners in how the grid is operated and those efficiencies that are gained from it. So we're flattening and lowering load shapes across entire community areas with these optimal DER portfolios. That's reducing system-wide peaks, which is the most costly energy and grid infrastructure. And that includes the tax that's on all of us. All of our utility bills here in California are taxed an extra amount for paying for a transmission grid, even if the energy doesn't use that transmission grid. So these are some of the centralized relics that we have to fix. And then local balancing manages the variability and volatility of energy locally rather than exporting that volatility as an aggregated issue up to the centralized system. So it solves that problem. And then again, it provides energy resilience and security to cities and communities via this power, some of the power generated, delivered, and consumed locally. So this brings us to the North Bay Community Resilience Initiative. So this is an example of heading towards the community microgrid model. And the objective is to make energy abundant, affordable, resilient, and sustainable. So these 5 objectives are covered here. So we're going to rebuild the fire destroyed areas with high levels of sustainability in the homes, the buildings, the grid. So both home side, building side, and the grid side, which enables this modern, distributed, and carbon-free system, delivering the substantial economic, environmental, and resilience benefits that we've been talking about. It provides a model for operating a modern distribution grid. So incorporating these optimal DER these distributed energy resources, doing the cost-effective local balancing, and full interaction with the transmission system. So that's the resulting benefits we get across both economics and grid operations. We're going to work on making sure the building codes are advanced to achieve more resilient, safer, and cleaner homes and buildings for communities. All of this is going to lower our costs. It's going to lower customer costs, ratepayer costs. So deferring and avoiding costs in centralized energy delivery, lowering the cost of using energy locally, reducing peaks, reducing the amount of money spent on transmission and distribution infrastructure. All that is the result of this approach that we are working on in the North Bay, and then establishing a blueprint for how to do this across other areas, not just disaster areas, but all areas. So with that, I'm going to hand this off now to Rachel Kuykendall from Sonoma Clean Power.
All right. And you guys can hear me all right, correct?
Sounds good.
Perfect. So my name is Rachel Kuykendall. I am our programs manager here at Sonoma Clean Power. And I was asked today to talk a little bit about our Advanced Energy Rebuild program. And this is a collaboration between us, PG&E, and the Bay Area Air Quality Management District. Just to sort of level set a bit about Sonoma Clean Power, we are what is called a community choice aggregator that started serving customers in 2014. We procure power for approximately 600,000 customers in California, Sonoma, and Mendocino counties. Like most community choice aggregators, Sonoma Clean Power was set up really with a mandate to help reduce greenhouse gas emissions within our member cities and counties. And that's really translated to how we procure power and also how we think about programs. So we're a bit unique from maybe a traditional utility in that the metric that really defines success for our programs is greenhouse gas reduction rather than straight kilowatt hour and therm reduction. We also have a distribution partner that distributes our energy that we generate to customers, and that's Pacific Gas and Electric. Because of that, most of our customers are also eligible for PG&E programs. So when we think about program design at Sonoma Clean Power, we really are thinking about how to help fill market gaps that are a little bit more tricky for a regulated utility like PG&E to address. Currently, all of our program dollars are our own dollars, so we haven't applied to be an administrator of CPUC funds like a couple CCAs have, and like all the investor-owned utilities are currently doing. So we can be a little bit more nimble with what we fund at Sonoma Clean Power. This has led to things like our flagship program, which is called Drive Evergreen, which is a vehicle incentive program for electric vehicles that was started back in 2015, really before any utilities were really starting to think about that as an incentive program and a way to drive greenhouse gas reductions in customer homes. And really through fall and summer of last year, what we've been working on is starting to transition from looking at vehicles, which are sort of our number one emission source in Sonoma and Mendocino counties, to starting to think about how to really engage in the building sector. So we've been ramping up pilot programs, looking at sort of some decarbonization options and how we can layer on to existing programs that exist within our service territory. And then really what happened was the fires happened. And that really fundamentally shifted where we're going with programs. We pretty quickly worked with our board and our community advisory committee to, for the first time, allocate a multiple year program budget for helping our community rebuild. And at that point, really, we just knew we had to give back somehow. And didn't really have a sense of what that program would look like. And what's come out of that is this Advanced Energy Rebuild program that was really propped up in a little over 6 months, so phenomenally quickly for the pace of typical programs in this space. Our program partners for this, we are really blessed to have these two organizations contributing to this program. And really, these are sort of three pretty strange bedfellows. We don't necessarily collaborate a lot traditionally because a lot of times the metrics that are defining success for our programs are pretty tricky and don't necessarily go well together. So jamming quickly through these organizations, the first of which is PG&E. And PG&E's program manager, Conrad, is actually on the call today. So Conrad, feel free to chime in if you have anything to add here. But PG&E has this really great program called the California Advanced Homes Program, which is active in our service territory. And really, I don't think we could have done this without having that program here. We're actually making use of much of their program structure, the program implementer, and they have also, PG&E applied to the CPUC for a doubling of the funds that can be allocated to customers through that program, and actually just received the go-ahead to do that. So we're really excited to use the California Advanced Homes Program structure and financing to feed into this larger program. That program is a bit unique from what you'll see here, in that really what PG&E is asked to report on is kilowatt hour and therm savings. So their incentive that they offer customers is variable based on that. And what you'll see is we really thought it was important to provide one number to homeowners that we could market and have them really understand what they were getting out of this program. So that's a little bit about the PG&E partnership there. We are also partnered with the Bay Area Air Quality Management District, and they're similar to Sonoma Clean Power in that really their motivating goal for what they're reporting on internally is greenhouse gas reductions. The funding structure is a bit unique as well. They are looking at putting dollars towards certain measures installed in homes, particularly heat pumps for HVAC, heat pumps for water heating, and solar PV. And so then that leaves us, and really what Sonoma Clean Power's role in this funding structure is to take these two rebate incentive amounts that vary quite a bit and backfill to get that one singular number that we can present to customers. Our goals for this program, and this is sort of speaking on behalf of Sonoma Clean Power, what we really wanted to achieve here in this program. First and foremost, we really wanted to make it easy for homeowners to participate in the program. We did that by, first of all, making sure the application was really easy for homeowners to fill out, not something that was an after the fact paper form, not something where they had to email a program administrator. It's all online. You're able to actually upload the documentation on that application. So it's really pretty simple process for customers. We also worked to go through the existing PG&E program implementer to get one check to customers, despite having 3 organizations that are funding this. We didn't want to give customers the additional headache of having to track down 3 separate checks from each organization. The second point here is we needed to look at just an increase of funds. What we heard pretty clearly from the get-go was that most of these 5,000 homes that were looking to rebuild were massively uninsured, to the point where folks had enough funding to maybe rebuild, a half of a house, which is not much. And the other thing that we had really going against us from the get-go was a real push from contractors and energy consultants that a lot of the existing rebates that they were used to were not worth the headache, that the dollar amounts were so low that really they were just not selling to the homeowners, that there were these options for additional energy efficiency in the homes. So because of those two, we really wanted to increase the incentive so that they can move the market and really make this a no-brainer for people to participate. The third point here is that we really wanted to think beyond the realms of a traditional energy efficiency program and take a look at incentivizing strategies that maybe looked at greenhouse gas reductions, looked at non-traditional measures like water or demand response or electric vehicles, and also measures that may be coming down the line in the next Title 24 update, the Title 24 2019 standards, and incentivizing those measures that have been proven cost-effective through that process now so that homeowners can take advantage of them. We also wanted to make sure we were offering as much of that dollar amount upfront as possible. So we've decided that 50% of the total rebate amount is issued basically when they go through the first plan check with the program after getting their permit. And that's been something that we've gotten a very positive response from customers. And lastly, we wanted to make sure that we were really creating a slew of resources for everyone involved in this process. We can't really just throw money at this and hope it works. There's a lot of education that's needed for architects, for contractors, for consultants. A lot of these measures we're recommending are things that maybe aren't traditionally built in homes in Sonoma and Mendocino counties. So there's a lot of training required to get folks up to speed on things like exterior insulation on homes and things like that. And I'll have a slide at the end that talks about some of those resources. All right, so diving into sort of the meat and potatoes of the program here, we have 2 pathways for participation and then 1 kicker. You'll see that for each of these options, there's sort of 2 ways to get that incentive amount. And this was really important to us because what we've sort of done here is we've broken out a performance-based pathway and then just a list of measures that you can do. And if you do all of those things on that second list there, we will give you that $7,500 number. And why that was really important to us was sort of twofold. The first that I'll talk about here is we really saw this as a way to engage homeowners. It was very difficult for homeowners to sort of look at a thing that said 20% better than Title 24 Energy Code and understand what that home looked like. What we found is that it's much more accessible to sort of have this list of, say, things like high performance walls or a high efficiency water heater. That was really something tangible that homeowners could take and understand and give to their project teams and say, hey, I want this in my home. The second point that's really important about this simple menu-based path is that it provided really a conversation starter between us and homeowners, where maybe they would be going for sort of these lower incentive levels, but they look at these items on this prescriptive checklist and say, hey, you know, I've never really thought about what a heat pump water heater is. Can you tell me more about that and what the benefit is of it? So really a good way to engage with our homeowners. We also have on this top option a performance pathway, which is more typical of traditional programs and one that tends to be something that resonates more with our builders and our energy consultants. It's a bit unique in that we are asking for some non-traditional measures here. So to get this $7,500, if you take the performance pathway, we not only require you to be 20% above current energy code, we also require that any gas appliances are pre-wired for a future switch to electric appliances, that the roof is solar ready, and that an electric vehicle charging station is installed at the property. That last one is pretty simple, as Sonoma Clean Power currently has an incentive program for charging stations for all our customers for free, and CalGreen already mandates a lot of that prep work to be completed as a part of the program. Down on the menu-based pathway, These are sort of a combination of mostly what gets us to the Title 24 2019 standards, with some other measures like those water efficiency measures, appliances that aren't traditionally incentivized in typical utility programs. But really our goal here was to sit down and think about what we should be promoting when these homes are rebuilt, and not just being confined to the sort of siloed energy efficiency world. The second pathway for program participants is called the all-electric home. And this was really important for us to be able to supplement the PG&E dollars, which are fuel agnostic, and really promote this as an option to customers directly. So again, you'll see two options for this, the performance-based pathway on the top and the menu-based pathway on the bottom. We originally called it the prescriptive pathway, and HERS raters sort of didn't like that confusion about it not mirroring the prescriptive Title 24 requirements quite as nicely as they wanted. And one reason, again, why this menu-based path was important, especially for this all-electric home option, is it can be really hard to get that 20% above Title 24 number when you have an all-electric home. I've done Title 24 for a number of net zero energy homes and businesses and multifamily properties where those buildings in reality are net zero, and it can be really hard sometimes to even get 0% above code for those buildings. So we thought it was really important to maintain that option at the bottom, where if you do everything on that list, we will give you the $12,500. All your Title 24 needs to say is that you're at least 0.01% better than Title 24. And then lastly, we have this kicker for either home. It's a $5,000 kicker, and a bit unique, again, because what we're doing here is not just talking about energy efficiency, but talking about renewables for that home in tandem with it. This has been something that's been really something that homeowners have been excited about and asking for, and is a bit unique in terms of what we're asking. There is the option, this top option here is a on-site option, and we also have the off-site option, which is a little bit funky, and I'll go into a bit more. That top option is a solar PV system with a 7.5 kilowatt-hour battery storage system. The PV system, we basically mirror the requirements of Title 24 2019, which is based on square footage. And that was something actually we sort of changed midway about this program as well. Originally, when we were putting it in front of homeowners to get feedback, this was, we were requiring a much larger PV system that fully offset the electric load. And what we really heard back from customers is that we were maybe making it more difficult for folks that were interested in electrifying their home to comply with this. And we were putting them at a real disadvantage. And so we adapted this to make it sort of a fuel agnostic size of the PV system paired with a battery. This option also evolved a bit throughout the program design. Originally, there was a much higher incentive for this kicker. And what we really started hearing back from folks was that people are starting to understand that there's financial payback for PV systems, and that maybe we don't need as much incentive here, but we should shift it to sort of the energy efficiency items where we're still getting some pushback from builders on some of these things in terms of costs. So the program shifted a bit as we started to put this in front of folks for stakeholder engagement. The second option here is this sort of new off-site option that we think can be a really interesting sort of scenario for community solar, but owned and operated by the utility. How this works is we ask folks to essentially pre-purchase a 20-year commitment to 100% local renewable power. And I have a very text-heavy slide that describes this. But essentially what we do is we would take the electric load assumed from the Title 24 compliance report. We multiply that over a 20-year period, and then multiply that again by the cost difference between utilities' standard product and their 100% renewable local product. For Sonoma Clean Power, that's about 3 cents per kilowatt hour. And then at the time that that home is built, we ask for that to be prepaid into an account. That prepayment dollars is used to fund additional local 100% renewable energy that can be delivered to the wider community. And on the back end, what that would look like is essentially that homeowner would be paying for just the utility standard product, but they would be delivered the 100% renewable product. So they would just be paying as usual for their energy usage over that 20-year period. This would be something that would be transferable. So if that homeowner were to move, this would remain with the property like a solar PV system that's on site. Again, this is sort of something we're starting to explore as maybe an alternative to community solar, which hasn't been as successful in our service area. But really, we think this is a product that most folks are doing on-site solar, and this would really be the product for folks that maybe have a very shaded property or something that's very dense, maybe a tall multifamily building. But something we've been working through internally and with the Energy Commission as well on what this could look like. And then a little bit, I guess, about program support, which is really, I think, what makes or breaks a program and makes it successful. We have first partnered with PG&E on a series of classes at the North Coast Builders Exchange, which is a resource locally for contractor trainings. And what we've done is we really took the requirements of the program and sat down and said, well, what's really difficult for contractors right now? And we targeted a series of trainings throughout the summer on a variety of topics, including, how to install exterior insulation, how to moisture-proof buildings, how to design really efficient HVAC systems that are properly sized, a whole bunch of courses that are really great. The second point that we're working on right now is certification courses. So the program requires both a certified energy analyst, a CEA, and a HERS rater for verification of, on the front end, the energy modeling, and the back end on the performance of the home. So we're partnering with KVEC and CalCerts to host those trainings locally and offer discounts for folks in our service territory that are working on these projects. And that's one thing we've consistently heard from builders is that there's just not enough people and resources to do these projects, and really that's been a bottleneck for them. Lastly, in order to sort of engage our customers on that all-electric home, we've created an induction cooking lending program where folks can actually come to the Sonoma Clean Power office and check out one of these little portable induction cooktops. And that's been a really good way to engage with. We've had production builders come in and check it out and lend it out to people who are looking to build with them, as well as just homeowners. And that sort of gets over the newness factor of induction cooking, and folks tend to really love it at the end of the day. And we think these are sort of fundamental strategies for really making sure that this program is a success and engaging with our community and helping them rebuild and understand what their options are. And with that, I am done. So this is my email address with my crazy long name. It sounds like the slides are going out, so don't worry about jotting down all of those letters, and happy to answer any questions either at the end or offline through email. Thank you.
Thank you, Rachel. Thank you very much. We're going to pass it along to John Sarter now for his presentation.
Hello, everyone. Can you hear me all right?
Can hear you just fine, thanks.
Okay, and screen's up. Thank you, Rachel and Greg, for that introduction and discussing some of the benefits and great programs that you guys are offering. I want to go into a little bit deeper about why 100% microgrid community development really makes a lot of sense. I'll discuss some of the benefits, and then we'll talk a little bit deeper into how to do it on a building scale. So the benefits, one of the benefits is having locally sited renewable energy for homes, businesses, and infrastructure. And what that means is you're going to have permanent, local, healthy, renewable energy jobs for people in your community, such as engineering for these systems, installation of the systems, maintenance of the systems, and management. These are some local companies and some local workers here doing some of this work. One of the benefits also of community microgrids is that if the surrounding grids fail, yours does not. And I think it's unfortunate that a lot of times we're seeing these efforts that are occurring after the fact. Disasters happen, such as they have in Fukushima in Japan, in Puerto Rico, and right here in our backyard in Sonoma as well. But what basically you have is some really different layers of resilience if you do this in the ways I recommend. You kind of have 3 levels of microgrids. So first of all, you have a building scale microgrid, which is often called a nanogrid. It's contained within that building. And over here on the far right, you'll see this building here. This is a 6-story structure we just finished in San Francisco that's completely self-powered and islandable from the grid in the event of a disaster, just by the solar being produced on the roof. So what I want to put out there right off the bat is that if we can do this in a 6-story building, we can easily do it in 1 or 2-story single-family homes. So you have the nanogrids. You'll notice I also have a lot of links in here, and you can refer back to these later to do a little searching and perusing as to what's available and what's out there. Beyond the building scale, then you have campus scale or critical service microgrids, and these are oftentimes fire stations or hospitals. These resources that really need to have full power all the time for communication and life support systems even. Over on the right, this is the city of Fremont's fire station microgrid project. I don't know when that was completed, but there's a link to it there. And then, of course, going beyond that to what we're talking about now, community scale microgrids. And on the lower right, this is a community in Japan, in something called the Japan Smart City Project. It's just really a phenomenal. As I said, the Japanese kind of have a head start on this, and they're very technology driven to begin with. So the benefits of this has really been made apparent to them and to other people globally. What I really want to emphasize is that we're not reinventing the wheel here. This is happening globally. This is a transition that is occurring. And sort of the danger that I've kind of seen in the U.S. is that we're getting a little bit of a slow start on this. And I really think that we need to step up and get with the program and get with the rest of the world and start developing these. This is a quote from Patton down here on the bottom that you've no doubt heard: lead, follow, or get out of the way. Another benefit of this type of local energy development is you have local energy for local transportation and even long-range transportation. We've all seen the release of the Tesla Semi that's going to be able to go across the continent basically on carrying a large amount of energy storage, greenhouse emission free, and charging along the way as needed. There's commercial vehicles such as the bottom right there that are fully electrified. And then of course passenger vehicles. And one of the cool things that are coming up with regard to all of these vehicles actually is vehicle to building and vehicle to grid infrastructure. And this is occurring in different places throughout the world, Japan, in Europe, Singapore, a number of different places, where your vehicle can actually be a sort of a mobile generator. So you could take the power in your car and either power your home for up to a week, because a vehicle holds a lot of energy storage compared to what's needed in a home, and especially in a very efficient home. Or it could even go out into the community where places in need power in the event of a disaster. And this will also allow new possibilities for mobile energy storage, transfer, and also microgrid and grid balancing through ancillary services. So the grid can actually export power into these vehicles and take it out as needed for balancing, because when you have a high penetration of renewables, sometimes there's big peaks of power in the middle of the day and they need places to put that energy. Another benefit is you are eliminating a very volatile source of energy in your homes and communities if you go all electric. You're also increasing efficiencies across all sectors, and you're replacing it with clean and largely locally generated electricity. And in this slide is some examples of some wind power. This is a new wind device that's coming online out of Oregon. This is a solar trellis on the building that we just completed in San Francisco. And down here is a way that up at Humboldt State University, they've devised to turn PV energy into hydrogen that can run fuel cells or even be stored for use later on, long-term energy storage. And of course, there's a community wind and solar farm here and some local wind. Now, this can be very cost effective in one way by eliminating an entire building system and community system, natural gas. I mean, it's expensive to pipe your home and to meter it and all the appliances for gas. So if you can eliminate an entire system within your building and your communities, it's not just greener and safer, but it can actually be very cost effective. And of course, it can eliminate the need for new power plants, peaker plants, and therefore facilitate radical reductions in greenhouse gases. So if you look at this is the 2015 California greenhouse gas chart here. 39.2% was transportation, 28% from the built environment alone. That's almost 70% of the state's greenhouse gas emissions. If we can convert these two sectors to locally generated renewables, that's huge. And there's no reason actually that we can't do this for agriculture and industrial as well along the way. Another benefit of what we're discussing here is zero reliance on outside energy sources and protection of our national environmental resources. To my knowledge, there have never been any wars fought over solar access in the sun. And it would also potentially free up the national budget away from a defense budget, perhaps toward funds for more grid modernization. Another benefit of producing your energy locally on the different three levels is you can export the energy for personal, community, and utility revenue. I think the greatest revenue benefit is to electrify transport, because gasoline is very expensive, the price is unpredictable, it's also very flammable, and has very high GHG emissions in its extraction, production, and use as a fuel. So monetary revenue can be derived from renewable energy export as well, and that will depend on feed-in tariffs that might be paid by your local utilities or the CCAs. I'm not sure if Sonoma Clean Power has a feed-in tariff rate for excess generation on a single home, but Rachel will be able to answer that question later. And then just imagine not having any transportation fuel bills and really minimal energy bills for the life of your home, your life and the life of your home. What that translates to is much higher home, property, and community values as a result. Over here on the right side, this is a screenshot from a Tesla Powerwall app, and this is an example of excess generation. This is on our building in San Francisco. And you can see this big solar production ramp here. This is for the day. And then this curve here is the energy use of that particular unit for the day. And then this down here is export to the grid. Now this unit doesn't currently have an electric vehicle, so all of this could be charging an EV. our projections are in this building that if the owners hit the targets that we believe they can, and it's going to depend on their usage and habits, of course, they'll have enough excess energy to potentially drive an electric vehicle up to 30,000 miles a year. So then the big question is, how do we do this? How do we do it as builders, architects, and designers? It really comes down to several different things, and one of them is siting and designing your building properly to take advantage of passive solar design. So you want to shade your building, obviously, in the summer to keep it cool, and you want to let sun in the winter to warm it up, and have some thermal mass on the inside, perhaps in the way of a concrete slab or tile work or something that you can heat up, and it'll radiate that heat back out during the evening as things cool down. So siting and design and building system efficiency is sort of the low-hanging fruit. The more you do on this end, the less you need in renewable energy resources to be a net zero building. And I want to emphasize that this is not rocket science. Any good design build team with a little bit of training can do it. And it really takes a good integrated design team to do it really well, in my opinion. So the first step is you want to site your home to take advantage of passive solar strategies, as I said, whenever possible. In addition to that, you want to allow a large south-facing plane if you have it available of your roof for solar, or maybe a plan where you have a solar trellis that could go on or over a patio on the south side of your home. This photograph kind of shows the trellis on the building in San Francisco I was discussing. What we did was raise it up over the roof deck, which is the outdoor space for the home, so it becomes a really nice architectural element. It lets filtered light through and produces all the energy needed for the building. Second step is you want to thermally model your exterior assemblies and reduce thermal bridging, which is where heat and cool can come in through the solid elements in your wall into the inside of your building. There's a couple different ways to do that. One is exterior insulation that Rachel discussed a little bit earlier. One of my favorites is Roxol. It's a mineral wool fiber that is non-flammable. It's basically rock that is ground up and made into sort of a spun wool product. Another way to do it, if you don't want to deal with exterior insulation, is strapping the interior walls of your building. And these are called Mooney walls. You should look that up. I did not put a link there. But basically, your studs in your wall they are thermal bridges, so they will transmit the heat and cold right through your wall from the outside to the inside. And that's why you either need that exterior insulation to create a thermal break, or this strapping can kind of do the same thing. And what strapping is a horizontal wood member, 2x2, that basically goes on 2-foot centers horizontally across the exterior walls of the studs. So instead of that full stud being a thermal bridge, you only have a little 2x2 section where that strapping is the thermal bridge. Greatly reduces it. Another good thing to do is try to keep your plumbing walls on the interior of the building. That way, all of your exterior walls can be fully insulated. Of course, you want to use fire-resistant exterior materials and wall assemblies. We all know the value of that. Third step is to make your homes and buildings very airtight. This also helps them become thermally efficient. And you do this by much better quality windows and doors than perhaps we're used to using. It's great to hear the incentives that Sonoma Clean Power is offering for this. Another great strategy and a way to make it airtight is a liquid applied water or air barrier on the outside. There's a couple different methods to air seal your building. You can tape the seams of traditional materials like plywood and OSB board. That helps, but liquid applied is really my favorite because you end up with a really durable, flexible exterior water and air barrier. And you've got to make your building waterproof to begin with anyway, so you might as well put a good product on that really does both. The fourth step is when you make a building that's very airtight, you want to add a heat recovery ventilation system. So basically, this is always bringing a constant supply of filtered fresh air into your building. And filtered is the key word here. When you filter this, and you can add up to HEPA level filters in these, you get a really super clean indoor environment. You can imagine if there's a fire in your neighborhood or in the area, and you're bringing in outdoor air without filtering it, you're going to get a much lesser quality air in your home. A side benefit of doing all of this is you get very quiet and very clean homes, because if it's airtight, you're not getting contaminants in from the outside. People in homes like this report that they hardly ever have to dust even, and the quiet is really nice to have. Again, it's a buffer against environmental contaminants. So if you use these 4 basic systems, what you end up with is a greatly reduced need for any additional and conventional heating, ventilation, and air conditioning systems. These 4 items are part of Passive House certification strategy, and I'll go into that next. It's sort of, so the Department of Energy, U.S. Department of Energy has a program called Zero Energy Ready Home Program, and they recognize Passive House certification plus their program as sort of a high bar for energy efficiency. So when you use these strategies that they embrace, you end up with a greatly reduced need, as I said, for on-site renewable energy and energy storage in order to power your home and create a nanogrid if you want to take it to that level. So again, you want very good quality airtight windows and doors, and you can take actually lesser quality doors sometimes and add some gasketing to make them more airtight. These 2 photos in the center here, this is a door that we had to have an ADA fire rated door in these buildings, and they don't exist in a Passive House certified door, so we made our own basically. We added a layer of trim around the interior of the jamb and datoed a groove into it, in which we applied a continuous gasket, silicone bulb gasket like this, and that basically made an airtight door out of a standard fire door. You want to add very high efficiency HRVs, as I discussed. For the higher efficiency, the better, obviously, but the air quality is something that you really get out of it. And again, you want that fresh air coming in, and you're exhausting stale indoor air at the same time. By the way, inside this is a heat exchange core. So when you're exhausting the air from inside your home, it goes through this heat exchanger, and it gives its heat to the incoming air. If you want to keep heat, same thing, it'll do the same thing for cooling as well. So if you use HRVs combined with low energy mini split heat pump HVAC systems that Rachel said there are incentives for, which is great, you have greatly reduced your energy need for heating and cooling. As Rachel also said, heat pump water heaters are a great way to cut energy use for all electric homes. My favorites are sand and CO2 heat pumps. CO2 is a refrigerant that is 10,000 times more environmentally friendly than traditional refrigerants. And pretty soon, sand and heat pump water heaters are also going to have the ability to do both domestic hot water and hydronic heating in your floors. Especially if your home is very efficient, as I said, you really don't need much heating, so it becomes very cost effective. Another great strategy is to use 100% LED lighting, ideally with motion sensor shutoffs in your home. You can have traditional switches that are motion sensors, or sensors in the ceiling, or you can use a home automation system like Radio RA, we call it Radio Raw, where basically the light will turn on as you move around the home and turn off behind you, the lighting and other systems. LEDs actually cost less. They're a little bit more in the upfront cost, but they cost less in the long run due to their very long life, and they're so much more energy efficient. Another strategy we used in San Francisco that is not difficult to do, it just takes a little pre-planning, is to do motion sensor receptacle load shutoffs. So basically, when you have a very high efficiency building that's not using a lot of energy, some of the vampire loads, they call them, for devices that you might leave plugged in, even your little phone charger adapters that you plug into the wall, they can end up being a pretty substantial use of the overall use of the energy in the home. So by doing this, you eliminate a lot of these vampire loads. One interesting takeaway from the project that we just finished in the city is that larger multi-unit buildings are actually more efficient and cost-effective and affordable to achieve these high levels of energy reduction in, because you have a lower interior volume to exterior surface ratio. So, that's another way to make housing more efficient and actually more affordable at the same time. So if you follow these strategies, then you're going to have a very low energy use home. And then now we're going to talk a little about pre-planning for renewable energy and energy storage systems and how to be nanogrid or microgrid ready. And as I said, the nanogrid is basically your home as an independent actor. If the grid fails or the microgrid fails, your home actually still stays on. I think this is a great way to go. And one question I want to ask Rachel later on about incentives for possibly energy storage, if that's part of their program. So now you've got this building that's very efficient, and how do you get it to either to net zero or plan for it? As I said, you want to make sure you plan an area for the solar, of course, and pre-plan any structural that might be required for it in your roof, or it doesn't have to be on the roof, it can be over a patio. You want to plan an area for energy storage batteries. Now, this can be outside the home, it can be in your garage, or even in the home. Most of these systems now are UL listed and indoor rated, which is great. It gives you a lot of flexibility in where you can put them. And some of them are actually quite attractive too. The Tesla Powerwalls, and we used a company called Blue Planet Energy. They have a system called Blue Ion. They're very, very nice looking systems. You want to have your electrical engineer, electrical contractor sort of design a plan with this in mind and give you a quote to actually install it. And of course, the easiest time to install this is when your home is new. You can finance it into your mortgage. But if you want to do it later, there are other mechanisms to finance it as well, like Property Assessed Clean Energy, or PACE. And basically, that is when you take the cost of the system and you pay it over time on your property tax bill. And I'm sure Rachel can tell us if that, I'm pretty sure that's available statewide, but you should check into that, of course, on your own. You ideally would install conduit and penetrations for solar power lines and energy storage system, or at least plan the routes and maybe take some photographs of where you would go, so you know when you go through the wall later, you're not going to be interfering with any other electrical wiring or plumbing and that type of thing. An interesting thing about this type of building is that your standard electric service should be fine for any future work you do in this regard, because basically when you have an energy storage system in your home, your building becomes very light on the grid. Our building in San Francisco, we disconnected from the grid entirely for 3 weeks, and it ran with an excess of energy with no problem at all. So basically, you're only exporting solar power to the grid and then bringing some, maybe bringing some grid power back at night for EV charging in a situation like that. It's also a very good idea, as I discussed before, vehicle to building and vehicle to grid is coming, so it would be good to run some wiring for that in advance. You just basically run an extra cable from your panel to your garage so that you can have a bidirectional EV charger that will take power from your vehicle back into your building later on, and then from your building it can actually be exported through your main service back to the grid, or there could be a separate grid connection as well. So the building I just described, if you go all the way to that level, there's a new program being developed by the U.S. Green Building Council and New Buildings Institute called Grid Optimal. And this building I've described, a nanogrid, would be a very grid optimal building in that it doesn't really impact the grid too much. Even though it's a fully electric building that has very little impact on the grid, it can be a grid asset even and provide ancillary services for the grid even. So that means if the grid has an excess of renewable energy on it, the grid could say, hey, we're going to pay you, whatever, 10 cents a kilowatt hour, that's just random, arbitrary, to give you some energy because we have an excess, and they would store it in your battery system. These are some of the things that are coming down as we move forward in the new energy economy. So the Grid Optimal initiative is a new rating system and metric. They're actually going to rate buildings according to their ability to be light on the grid. And the role of buildings, renewable energy, and storage in the utility industry is changing, and near-term solutions are needed to address today's challenges and capitalize on the opportunities for market transformation. New Buildings Institute and the U.S. Green Building Council are launching a multi-year effort to develop a comprehensive grid edge initiative that will refine and disseminate a new building rating system called Grid Optimal. They're currently assembling a team of utilities and other partners who can advise and support this groundbreaking project. So that's all I have to say. I've put a lot of links on there in my slides, and I think we have some time for some questions after this, and I believe Greg is going to finish us up here. I'll pass it to you, Greg.
Thank you, John, and thank you, Rachel, both. And we will open it up now for questions.
Great, thank you. Yes, this is Josh. I'm just going to show the presenter contact information. If anyone has questions, additional questions, you can email Rachel or John. And actually, Greg, can you bring that slide up? I'm going to field the questions. If you can bring that slide up, that would be great. All right, so this one comes from Van Rainey from East Bay Clean Power Alliance. Van asks, does recent state mandate for solar on all new homes apply to those homes being rebuilt from fires? And anyone can feel this. If you're on mute, please unmute yourself.
Can you repeat that question, please?
Sure. Does recent state mandate for solar on all new homes apply to those homes being rebuilt from fires?
That's a good question. Conrad, I would assume it would.
This is Conrad with PG&E now. Anything that is Title 24, 2016 code is what you're going to be building under. So we are we're making incentives that would push people towards that 2019 code, which is what has just been announced as everyone's saying, oh, now we're going to have solar on our homes, et cetera. So that is coming in 2020 as the mandatory, but people in Sonoma and building on 2016, Title 24, 2016 code are not required to have that. There are options. It gets complicated, but basically no.
I'd like to add, though,
I should introduce myself. This is Conrad Asper with PG&E, and I'm supporting Rachel in this.
And John, you were going to chime in there, is that right?
Yeah. I just wanted to say that, with the cost of solar where they're at and the benefits, even the economic benefits that I'm seeing, and the revenue models that are opening up, I just think anybody who's building a new home, if they have good solar access, would be doing themselves an injustice not to really explore it and consider it and install it, in my opinion.
Great. Well, thanks for your insights. I'm going to go to the next question. This one comes from Craig Lewis. He's the executive director for the Clean Coalition. Craig asks, does the estimated annual load include the EV charging? If yes, then people are covering their electricity and car fueling costs in their electricity bill, correct?
Is this a question, maybe we can get some clarification on the prepayment option? If so, it does not include the vehicle because it's based on the Title 24 report.
Okay, thank you, Rachel. This one comes from Steve Mann, an energy consultant with Home Energy Services. And Steve asks, the 20% above Title 24 numbers are 2016 energy code based, correct?
That is correct.
Great, thank you. And
I'd like to make a quick comment on that. And, Rachel, you mentioned how it's difficult to hit Title 24 numbers if you go all electric. I agree with that. I've had the same experience myself. And I think that's something that really needs to be addressed in the Title 24 because you're sort of penalized for using electricity. And this is sort of an old way of looking at things. They were encouraging gas and saying it's best to be dual fuel when really the logical way to go is all electric. So I think those are some issues that could be addressed within the Title 24 code and should be going forward.
Yeah, it does get slightly better in 2019, I will say. So I'm really encouraged to see where the code's going in the next cycle in terms of combating some of those issues with building all electric. And that's one of the reasons we did include that prescriptive option was really where we're at now, where folks are complying with the 2016 code. It can be really hard.
Great, thank you both. Steve also follows up with another question. He asks, how do you prove annual electric usage offset for advanced energy rebuild?
I believe this might be another question about the prepayment. And if not, Steve, feel free to clarify with me offline. We are not planning on doing any verification of that number. We feel pretty confident that that will be somewhere in the middle, and that we will have folks that that is an overstatement of their usage or an understatement. And really what we're doing here is exploring this as a small pilot and getting to the bottom of some of those questions. But currently we aren't planning on doing any sort of back-end adjustment of that prepayment number. It's just purely based on the Title 24, so for simplicity's sake.
Fabulous. Thank you, Rachel. We have a question from Farouk Rahimi. He's the Senior VP of Open Access Technology International. Farouk asks, does the Advanced Energy Home require compliance with Open ADR 2.0 on the part of the homeowner?
It's a great technical question. What we ask for is we ask for some grid integration, mainly in our all-electric home, but we do ask that heat pump water heaters be grid connected. Right now, the water heater vendors are sort of split on whether they use Open ADR or not. So happy to take that offline about what our experience has been in terms of communicating with these devices and what that landscape looks like. But we are planning to allow for flexibility while the market is sort of in this stage of determining what that protocol looks like for communicating with devices.
Great, thank you, Rachel. So we should probably end this now. We are a couple minutes over, but I'm going to end it with a question from Michael Sia, an instructor with UC Berkeley Extension. And Michael, I apologize if I pronounce your last name incorrectly. Michael asks, the ordinary distribution grids aren't well built for accepting and delivering the large amount of cell-back renewable power generated by microgrids. Has that obstacle been overcome by the utility industry? If yes, how is it done?
This is Greg. I will address that and quickly and just say that the physics of the distribution grid actually support quite a lot of two-way flow of energy. And yes, there are constraints, but those constraints are being dealt with as the utility model is being advanced to one of supporting a lot more distributed energy resources and local generation and advanced homes, such as what Rachel and John have been talking about, so that they can become operators of a distribution grid that's much more dynamic and two-way and better suited for the economics of clean energy and local energy optimization, as has been discussed here. So that's all advancing, and that's happening in across the country in multiple states, multiple initiatives, even at the regulatory level in evolving how utilities are compensated for operating the distribution grid in this way. And I think that is the future of the grid and the future of our communities.
Add to that, if I could, we have a great example in South Australia of a relatively easy and fast way to uptake any excess renewable penetration. Tesla just installed what they call their big battery there, and not only has it revolutionized and outperformed any other ancillary services available there, it's cut the cost by 90%. So in 4 months, that utility has saved $35 million in ancillary service charges. So, and that went in, I think they installed that in under 4 months. That was sort of a gamble that Elon Musk took on, that he would give it to them for free if he couldn't perform. Oh, it was 100 days, I believe, yeah. So, that's what can be done at a utility scale, in my opinion.
Great, thank you, John. And that's a perfect way to end this webinar. So thank you both, Greg and John, and also thank you, Rachel and Conrad, for contributing to this webinar. I should have put Greg's contact information on there on the slides as well. So if you wanted to contact Greg about the North Bay Community Resilience Initiative, you can email him at greg@clean-coalition.org. I also want to show you the main page for the initiative, which you can access on our website. If you go to our work under Community Microgrids, you see that on your screen, and go to North Bay Community Resilience Initiative, and it has all the work that we've been doing so far on the initiative. I also want to point you to our upcoming webinar, which happens not next week, but the week following on June 5th. This is our next webinar in our PAKE initiative, the Peninsula Advanced Energy Community. That will happen June 5th at 11 o'clock a.m. Pacific time, streamlining the interconnection of advanced energy solutions to the grid. You can sign up for that on our website if you go to news and events and upcoming events. So we hope to see you there, and we'll see you at another few more webinars in mid to late June and possibly July, and we'll let you know about those sooner than later. So thanks everybody for attending, and we'll see you next time.